All right, so the problem reads, the formula for surface area of this rectangular solid shown is 2 length times width plus 2 length times height plus 2 length times 2 width times height, where L represents the length, W is the width, H is the height of this solid. Doubling each of the dimensions L, W, and H will increase the surface area. Another way to say surface area is the area of the surfaces by how many times its original size. So fortunately, this idea of a surface area, the name speaks to what it is that you're determining. Surface area is the area of all the surfaces. It would be your job to realize that this formula, length times a width times 2, makes sense. You've got a length, okay, and you've got a width of the bottom of this shape. The area of the bottom of this shape is a rectangle. The formula for a rectangle is length times width. Length times width. I don't like to write in books, but I'll make it very light, and then I'll erase it right away. All right. So hopefully you can see the three-dimensional nature of this shape. The base, the width, and the length. The area of this shape is length times width. And the reason why they say 2 length times width is because there are 2 of those surfaces. There are 2 of those surfaces. Then there's a length times a height. There's a length times a height. That's the area of this side surface. And then there are 2 of those. So that's where this formula came from. All right? That's where this formula came from.
That's okay, thank you.
All right? What we've got is this shape that at first was length, width, and height. But what they want to know is, what if you double each of these sides? It says doubling each of the dimensions will increase the surface area by how many times its original surface area. All right, so what you do is, let's zoom out a little bit so you can see both shapes. All right, so now let's draw a similar size shape, but we're actually doubling each of the dimensions. All right, something like that. So now instead of L, let's call this 2L. Instead of W, let's call this 2W. Instead of height, let's call this twice the height. Now what we're going to do is we're going to find the surface area again of this larger shape. All right, so the way you find the surface area is to observe how many surfaces you have. Hopefully you can see that you've got a front here and an equal area, the same area on the back of this region, the shape. And then you have an area here on this side. Well, there's an area on the right side, but there's also the equal area on the left side. That's 4 areas right there. And then you've got a top and you've got a bottom. There are 6 areas you need to account for. Well, the area of this front side, over here, the area of this front side was height times length, and then there are 2 of those. So you multiplied by 2. Well, here you have twice the height times twice the length, and now you've got 2 of those. You've got 2 of those. So you got to multiply that by 2. Multiplying twice the height times twice the length times 2 is finding the surface area of this front surface and its back. All right, so this is front and back. Well, then to that, you're adding the area of this surface and the area of the right surface and the left surface. So that would be the area of this surface here would be twice the width times twice the height, and then there are two of those surfaces. So that would be multiplied by 2. And then, so that would represent the right and the left areas. All right? And then, this is the front and the back. This is the front and the back. Front and the back. And then, what you'd have to do is observe that there's a top and a bottom area. So the area of this top would be twice the length times this dimension here, twice the width, and then you'd have to multiply that by 2 because there are two of those surfaces. So what you end up with is 4H plus, or excuse me, I'm sorry. Forgive me. You'd end up with, this is 4 times the height times the length. This would be times 2, added to 2 times 4 times the height times the width, plus 2 times 4 times the length and width. So now what you have is you have 8 height times the length plus 8 height, 8 times the height times the width plus 8 times the length times the width. All right. So whereas here you had in the original problem you had twice the length times the width plus twice length times the height plus twice the width times the height. Here you compare that with 8 times length times height. Here you have 8 times height times the width, and here you've got 8 times the length times the width. Well, hopefully you see that this is 4 times as big as that. All right? So the surface area here is 4 times as big as that. And the original question was, it says doubling each of the dimensions increases the surface area by how many times its original size? Well, hopefully you see that the answer here, even though you double all the sides, that increased the overall surface area by 4. All right, so the answer there would be B. This is a problem. It says the inside dimensions of the rectangular picture frame are 15 and a half by 24. All right. It says the inside dimensions are 15 and a half by 24. The outside dimensions are 20 by 28 and a half. Then it says, what is the width in inches of the picture frame? All right, so they want you to solve for this W here. Solve for W. Well, what I'd like you to be able to see here is that they're giving you this overall dimension, which is 28 and a half. And they're also giving you this dimension in between here as 24. So there are two ways that you could go about getting this answer here. All right, first way is to see that if they give you this as 24 and then they give you this overall dimension as 28, the dimensions that they have not included in this 24 are the actual width of the picture frame. All right, so if all of this is 24 and then the overall length of the picture frame is 28, the difference between these two numbers would represent this width added to this width here, because that's not included in 24. So what you should do here is be able to subtract 28.5 minus 24. That would give you 4.5. That would give you 4.5. And then that 4.5 would have to be divided by the two widths that are not included in the 24. So you'd have to divide this difference by 2. You take 4.5, you divide that by 2, and you'll end up, with my students, we've done that a number of times before. That's 9 over 2 divided by 2. And then to solve that, you'd end up with 9 over 2. You'd multiply by the reciprocal times half. You'd end up with 9/4. Well, 9/4 can be simplified into 2 1/4 inches. So that would be the width. The width of, so the final answer would be H there. Final answer would be H there. Final answer. So you could also do this same problem. You could find the width by subtracting 20 and 15.5. 20 and 15.5. That would be 4.5. You'd end up dividing 4.5 by 2 again, and then you'd end up with the same 2 1/4. So that would just be mastery level understanding, getting the same answer in more than one way. A square 2 feet on a side is cut out of a circle with a radius of 10 feet as shown in the figure below. Which of the following expressions gives the area of the shaded region in square feet? All right, in square feet. So you've got some huge circle. You got some huge circle, and then someone went in and cut a hole in it. Imagine that's a pizza or something like that. You got a pizza, and here somebody comes and they cut a square out of your pizza. They took and they went and ate it. Well, the reason you would be upset if someone did that, because someone subtracted out a part of your pizza. All right, so the point I'm trying to make is the way you're going to find what's left over is to take an area that you had initially, and then you're going to subtract out the area of another region. All right? So with that in mind, let's go on and let's do what they're asking with this problem, which is to give the area of the shaded region the area that's left over. The way you go about doing that, let's zoom out again. The way you'd go about doing that is you would realize that you have the area of a circle. Initially, you have the area of a circle, and then you're subtracting out the area that someone might have went and cut out. You're subtracting out the area of a square. You're subtracting out the area of a square. Okay? So I hope that makes sense. How are you going to find the area of the shaded? How are you going to find the area that's left over? Well, you're going to have to start with a circle that's filled. The circle's completely filled. You're going to find the area of that circle, and then you're going to subtract out the area that someone would have cut out, the area of a square. So now, the formula for the area of a circle, you'd have to go into the problem knowing that the formula for the area of a circle is pi r squared. And you'd have to go into the problem knowing that the formula for the area of a square is base times base, or base squared. It's really base times height, but the base and the height are the same. So I just put base times base. All right? So let's read the problem one more time. A square 2 feet by 2 feet, 2 feet on a side. So the base of the square is 2 times 2. 2 times 2. And then it tells you of a circle with a radius of 10 feet. Now, the radius is 10 feet, so they're telling you what to substitute there. So now you have pi 10 squared. All right, pi 10 squared. And now what you would end up doing is notice that the answers that they offer you, notice the answers that they're offering you are really, they're not looking for a numeric value here. They're not looking for a numeric value here. All right, they just want the problem simplified. So what you have here is you have pi, they're not looking for an answer, 10 squared minus 2 squared. Don't even bother trying to simplify it. And hopefully you see that the final answer there would be E. Final answer. All right? And that's what we would want you to be able to do. What is the perimeter in feet of this region here? What, in other words, you'd have to know that perimeter means the distance all the way around. What's the distance all the way around? Well, notice how they don't give you two lengths to determine what that perimeter is. But the thing that I'd like you to be able to see is if I told you that this was, let's say, a shape that looked like so, and I told you that this distance was 8. If I told you that this distance was 8, it really doesn't matter what this individual length is here and this individual length is here. This could be a 1 and this could be a 7. This could be a 2 and this could be a 6. If you need the distance all the way around, it really doesn't matter what these individual lengths are. The only thing that really matters is if they give you that's 8, the sum of these distances must be 8. So that said, that is the backbone of this problem that we're working with here. That's the backbone of this problem that we're working with here. All right, so let me try to draw this a little bit larger. Try to draw a little bit larger and try to attack this problem. All right, draw it a little bit larger. Okay, so what they gave you here, they gave you this distance was 14. They gave you this distance is 14. They gave you this distance is 26. They gave you this distance as 15. And they gave you this distance as 5. All right, so those are the dimensions of this figure here. So how are you going to get this distance all the way around? If this distance is 14, and they gave you this is 5, you'd have to be able to see that this missing length would have to would come from the sum of 5 and this length here. So 5 plus what would give you the 14? Hopefully you see that this distance would be 9. That distance would have to be 9 because 9 plus 5 is 14. And then, similarly, if this distance here is 15, and they told you that this overall distance was 26, well, then that would tell you that this distance here would have to be 11, because 11 plus 15 would add up to that distance of 26. Now that you've got all the sides of this polygon, this figure, you would easily be able to figure out the perimeter. So you'd add these two sides up. That's 29. 29. So you would have counted those two sides. You add these two sides up. That would be 20. All right. And then that takes care of those two sides. And you add these two sides up. And that would be 31. 31. All right. So now you'd find the perimeter by adding all these sides up. You'd get, that would be 10. You carry the 1. You'd get 4 plus 1 is 5 plus 3 is 80. So the perimeter or the distance all the way around for this particular problem would be C. would be C. That the answer would be 80. All right, final answer.